Hi everyone. As you may have already figured out, this talk is about two things: object algebras and HTTP libraries. But in fact, there is more into that. This talk is about solving problems, solving one particular problem that I had and that I would like to start from. So, meet the boss, the ultimate source of truth, the ultimate source of requirements, the Almighty. He comes to you one day and he says, we need a new API. Let's say you have users database, you have users inside, and you want to expose a single endpoint that will allow you to search for users based on their name. Simple as that. So what do? You check out what is a current most fancy HTTP library, and it turns out it's akka-http, so you just go down to code and implement that. So you define your endpoint, you say there is a path, the path is user search, there is a single query parameter called name, and this endpoint is invoked by a get method. Okay? You extract your name parameter from the request and you pass it to your business logic. Your business logic returns a future of option of user, so this gets serialized and your request is completed. Nothing really interesting here. But then, when you think it's done, the boss comes again and says, we need the front end. So you start again. You're luckily enough, you don't have to write it in a pure JavaScript. You can use Scala.js. But you're still bound by JavaScript internals, so you write a client using XML HTTP request. So you define some method that takes the name of the user, and you invoke your endpoint with a get method with the user search path with your query parameter. If the status is OK, you just parse the JSON, decode the user, blah, 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 and you call your callback. And you're done. But the boss comes again and says, we need a client. So it turns out your web service is so great that you're going to have 10 new microservices. Each of them will be calling this one. So you want to create a library for your clients so they don't have to replicate the effort. So you choose the most fancy HTTP client, which is, of course, STTP. And you define a method, it takes the name of the user, it returns a future of option of user, and you invoke it with the get method, with the given path. You say that the response is a JSON, there is a user inside, and if it's success, you just take the body. OK, but the boss comes again and says, we need the documentation. It turns out the API is going public. OK. So now you have a problem, but not a big one. You will just write some YAML file or JSON file with Swagger documentation. And you just say, there is a user search, there is a get, there is a name, there is an application JSON inside a body, and there is a user inside a JSON. Done. OK. And I have done that a couple of times. And every time I did that, I had 4 words in my head, 4 words shouting very, very loudly. And these words were, do not repeat yourself. OK? Yeah, so this is how I felt, basically, at this moment. So I had a problem. And what do you do when you have a problem as a software developer? Like, really? You ask a question on Stack Overflow. So I asked a question on Stack Overflow. I said, I want an RPC library, but I wanted to keep HTTP semantics. I want some code to be shared between client and the server side, and so on and so on. And I got an answer. So Julien was so kind to point me to his library called endpoints that do exactly that. And in a time, I joined him in the effort of development the endpoints. So what this library is about. It's basically an abstraction over HTTP that will allow you to solve the problem that I had with the repetition of defining HTTP protocols. So let's see how it looks like. You start with defining your API. You just create a trait, and you extend this trait with a couple of different traits from endpoints library. Then you just say that there is something like user search, and this is an endpoint. The request carries a string, and the response carries an option of user. And this endpoint is defined as this. So it's a GET request to the path user search, and it has a query string parameter name. The response for this endpoint is just an optional JSON response carrying an user. And you define your case class here as well, so you can ensure that the encoding is matching on the both sides, but it's not really crucial. OK, so you have defined your endpoints. And what do you next? You probably want to define the server and the client. So let's see how it would look like. Oh, not this one. Yes, so the server side. You start with defining a class, and you extend your previously defined API. Then you just mix in a couple of traits. They are called the same as the one we have used before, but they come from different package. So here they come from akka-http server inside the endpoints library. And all you have to do is you say that the user search endpoint is implemented by an async operation, taking a name of the user and invoking some business logic. And the type that you get from this call is a native akka-http type root. So then you just instantiate your class, you bind the root to the port, and your server is up and running. OK, so the next step, the client. You start in the exact same way. You create a class, you extend your API, you mix in a couple of traits, and you're done. You don't have to do anything more. All your previously defined endpoints has become client calls. So you can invoke any of the previously defined endpoint as we do now and just get the answer. So because the Scala.j is synchronous client, it's an option of user. For other backends, it will be other type, but you will see that later. OK, now the documentation part. So to get documentation, we need to modify our API definition a bit, because we have to use some slightly different vocabulary to build it that will allow us to pass documentation to some of the methods. So you just put strings there. And one more thing you have to do is you have to provide a JSON schema for your responses, if they are JSON responses. But endpoints give you a way to for generic derivation of JSON schema for case classes and so on. So it's one line more. And then you just take your API definition, you mix in a couple of traits, and you end up with basically a case class that represents the open API, which is new Swagger documentation that can be just converted to CRC, to the JSON with CRC directly. And you're done. So simple, isn't it? So before we go forward, and before I explain how it is achieved, let me reiterate over what we have seen. So we have a single endpoint definition in a shared code. Then on the server side, we provide only the business logic. There is no HTTP semantics involved. The client and the documentation is basically for free. And by for free, I mean it doesn't change with adding new endpoints, for example. So there is no code specific to the specific endpoint. And everything is type safe, so there is no casts and so on, and it's macro free. No single macro was written when creating this library. OK, so what is the current status? We have the backends for akka-http and play, both for clients and server, so we can easily integrate this. We have also a simple ScalaJ client backend and XHR for Scala.js. We also have CRC and play.json support for serializing your case classes and OpenAPI support for documentation. But few words from Gary Oldman. Yes. So there are still a lot of things to be done here. So we would like to have more backends, especially HTTP4S and STTP. But one thing that I'm very excited about is the compatibility check. So with the abstraction that we have over HTTP, it turns out it should be quite easy to allow user to automatically verify if their current endpoints definition is compatible with the previous one. And this may bring a lot of value to the APIs that are public and has to be stable with the changes. So it should be quite easy to do that, but it's not done yet. But hopefully, maybe someone. Yeah, one thing that is also quite nice is boilerplate free CRUD. So create, read, update, delete. I have done that. The code is ready. It just needs to be integrated into the library. So with the abstractions we have, you can basically write the whole RESTful CRUD in a completely generic manner. So you just specify the types and everything is done. It's not very useful because you typically have more business logic inside, but if you need some proxy to the database, you can do this with one line, more or less, without macros. OK, so what are the alternatives to endpoints? There is Swagger, CodeGen, Thrift, Protobuf, but all of these approaches are basically based on code generation. And it's fine if you like to live with generated code, but I don't. There is AutoWire, Remotely, and Lagom, which are basically RPC libraries. And the problem with them is that you can't specify HTTP semantics, and because of that, you cannot achieve RESTful APIs. And there is FinTrospect and Row, which are quite similar, but FinTrospect is specific to Twitter ecosystem, and Row is kind of in progress or not ready yet. So not much of an alternative. OK, so object algebras. The pattern that we use to implement this library is called object algebras, or object algebras sort of, because the original object algebras were defined for a simple language like Java or C#, and encoding in Scala is a bit more complicated to make it more convenient to use, but I will keep the name because it's simpler that way. So before I start, this is how I see Scala community sometime. And I have to admit, I like pure FP very, very much, but I have to make a confession. I like object-oriented programming as well. So I think it's basically orthogonal to functional programming, and we can have some nice fusion between it. Maybe not all the time, but in some cases. And what object algebras is, or are, is basically tagless final plus inheritance. And let's see how it works. So you start with something called algebra, which is a basic vocabulary to describe your domain. And here we want to model request bodies. You have an HTTP request, and the request has a body. So what we do to model this kind of thing? We just say there is something called body. We have completely no idea what it is. but we know that it carries type information T. And there are 3 predefined bodies. There is a empty body, string body, and web form body. That's all we have to do. That's how we model the request bodies. Let's see a few more examples. We want to model requests. And to do that, we say requests consist of request bodies and URLs. And there is something called request. It carries type information T. And there is a method to create a request as long as you can give us an URL with type information U and the body with type information B. And when you call it, you will just get a request that carries type information U and B. It's a little more convoluted in practice, but that's the basic idea. And how do we model endpoints? We model this in the exact same way. We say that endpoints consists of requests and responses. And there is something called endpoint that carries 2 type information. So one in the request, one in the response. And you can create an endpoint as long as you can provide a request and the response. So that's how you model stuff. And that's basically what we have used in defining our API. And then you have an interpreter. Interpreter is basically an implementation of a trait. So in this example, we will be using play, and we say that the body is basically a body parser. And the web form body is one of the predefined play parsers. So to create an interpreter, you don't even have to write a lot of code. You just have to find good types, and probably there are already instances you can use or create quite easily. So the second example, here we want to use akka-http, and we want to interpret what is a response. So we say that response is basically a function from A to root. So as long as we can get type A, we can complete the request. And what is a text response? It's just a function that takes the body, and it completes handling of the request with status code OK and a body. Simple as that. And now the usage. So this part you have already seen. Because here we just, on the API side, we just use our abstract vocabulary to build the endpoints. And then we just mix in the interpreter to give it a meaning and get something meaningful. And that's how our endpoint changed the exposed method. So on the server side, we had implemented by async, and on the client side, we had a call method. So they came from the interpreter that specify what the endpoint is. So now the extensibility. This approach has one big advantage over tagless final, at least as far as I understand. And here are a couple of examples. So the first one is that you can deliver partial interpreters. You can specify some of the methods, or some of the types, or some of the types and methods. And you don't really care, and you can leave something for another interpreter. It is useful. We have used that, for example, in JSON support in the library at some point, but it's no longer there, I think. The biggest advantage is adding custom vocabulary or implementing missing interpreters. So let's say there is something you don't have in the library, like support for some part of HTTP or whatever. So you just add more vocabulary to your API definition. It's basically an abstract method. Here we want to introduce custom validation. So we just say there is a function that takes the response of type A and transforms it to response of type either of my error or A. And your interpreter, or so your server side, will have to implement that method. And that's it. The same is used when you have some algebra defined for on your API level, but not available for the given backend, because maybe some backend is missing support for, I don't know, optional responses. So you just will have to implement that on your own, but that's not a big deal. And the third advantage is that it's extremely easy to fix bugs or accommodate the implementation to your needs, because let's say you want to add cross-origin resource sharing headers to your responses. And maybe there's no support for that. So you basically override a specific method. You give it a new meaning. You add your custom code there, and it works. Yeah. So that's why I said that it's basically a tagless final plus inheritance. If you wonder how it compares to free monad, there is a very good article on free versus tagless final, so you can check it out. And yeah, so when I joined the project at the very beginning, my first question was, why the hell we're using inheritance? Like, it makes no sense, right? The first thing they tell you once you learned Java is that you should prefer composition over inheritance. And it turns out there is a good reason for that. And that's because all interpreters we want to use have to agree on the same type members implementation. Because in many cases, you use more than one interpreter for a given API. And because of some bug in Scala, the class constructors doesn't work with type members, which are also called dependent types. And because of that, all type members must become type arguments, and endpoints has more than 10 type members inside. So you will end up with a type like that. And good luck with carrying this everywhere. Yeah, so we are stuck with inheritance for a while. OK, and here are a couple of resources. There is a link to endpoints. There is a link to the original paper describing the object algebras. There is a link to paper about endpoints that we wrote with Julien. And I have to ask you, please, don't repeat yourself. There is my name, there is my Twitter handle, there is a link to the slides if anyone is interested. Thank you all.
Thank you very much.